Chapter 2, Section 1 is in regards to solving linear equations in one variable. We will be focusing on solving equations in one variable and identifying conditional equations, contradictions, and identities. The first thing we need to be aware of is what is a linear equation, especially if a linear equation. And a linear equation is a first-degree equation where the highest exponent on the variable is 1. Examples include x plus 1 equals -2, x minus 3 equals 7x plus 4, 2k plus 5 equals 10. Non-examples include x squared plus 3y equals 5, because we have an x squared. 8 over x equals -22. This is the same as 8 times x to the negative first. That is not an exponent of 1, it's -1. And the square root of x equals 6. It's the same as x to the 1/2 equals 6. So again, an exponent of 1/2 not being an exponent of 1. So a couple of reminders with solving equations. If we have parentheses, we can distribute in 3x minus 6 plus 3. The 3 is not in parentheses. Distributing on the right side, 2 times 6 is 12 minus 2x. Also, if we have like terms, so numbers or variables that can be combined on the same side, we want to combine those. So 3x minus 3 equals 12 minus 2x. And then you can solve from there. In doing so, you want to get the variables to one side, so adding 2x, you have 5x minus 3 equals 12. Getting the constants to the opposite side, so adding 3, 5x equals 15, and then dividing by 5, x turns out to be 3. In solving equations with fractions, we want to look for common denominators. One way is to find the common denominator, in this case 15, and convert all of the fractions to have a common denominator of 15. So multiplying the first fraction by 3 over 3, we have 3x minus 9 over 15. Multiplying the second fraction by 5 over 5, we have 10/15, and the last fraction stays the same. So we have equivalent fractions with a denominator of 15. And now to cancel the denominators, since we're dividing by 15, we can also multiply by 15. And in doing so, we can reduce, because multiplication and division undo each other. And so the denominators cancel out, and you're left with an equation with no fractions. In solving that equation the rest of the way, you end up getting x equals 11/2. The second method that you can use is multiplying by the common denominator of 15 from the beginning. And so we're going to do that to both sides. And so in doing so, multiplying on the right side, the 15s would cancel out, and you're left with x plus 12. When you distribute on the left side, you end up having 15 times the quantity x minus 3 over 5, and 15 times 2 over 3. In that scenario, the 15 and the 5 would reduce to a factor of 3, so 3 times the quantity x minus 3. The second fraction, 15 and 3, would reduce by a factor of 3, and you're left with 5 times 2, and then equals x plus 12. If we distribute, we have 3x minus 9 plus 10 equals x plus 12, and you can see that you are back to the exact same spot you were in the first scenario. Again, solving that equation the rest of the way, you end up with x equals 11/2. Now, what to do if you have a fraction outside of a parentheses? Two things you could do. First, you could distribute, and so you'd have 1y over 4 minus 4 over 4 equals 1y over 5 plus 2. And that is the same as 2 over 1. If we focus on our common denominator, in this scenario for 4, 5, and 1, our common denominator would be 20. And so getting equivalent fractions, we'd have 5y over 20 and negative 20 over 20 equals, multiplying by 4 over 4, will give us 4y over 20, and 20 over 20 will give us 40/20. We're now back to the situation where we can multiply by our common denominator of 20, and when we multiply it and distribute, multiplying and dividing undo each other, and we're left with 5y minus 20 equals 4y plus 40. Solving that equation the rest of the way, you end up with y equals 60. The second scenario of multiplying by the common denominator of 20 from the get-go is slightly unique because now we have a parenthesis within a parenthesis. On the right-hand side, 2 times 20 turns out to be 40, and then 1y times 20 is 20y over 5, and that just reduces to 4y plus 40. That's pretty straightforward. On the left-hand side, it gets unique because we have 3 items that are getting multiplied together. Think of doing 2 times 3 times 4. In that scenario, you do 2 times 3, which is 6, then multiply by 4 to get 24. So in this scenario, I'm going to do 20 times 1/4 first, and so that gives me 20/4 times the quantity y minus 4. And 20/4 reduces to 5, and then you have the remaining term y minus 4. You can now distribute 5 into the parentheses, and you have 5y minus 20 on the left side, bringing down the 4y plus 40. In that situation, again, you end up in the exact same spot, exact same equation, which would result in giving you a value of y equals 60. In this next example, we're looking at what happens when you have a subtraction of 2 fractions. In this scenario, I want you to think of subtraction as adding the opposite. In doing that, we change that subtraction to addition, and we have a negative x and a negative 2. We can then go forward, work with our common denominator, in this case 6, and so we would have x minus 1 over 6. A second fraction, making that equivalent with a denominator of 6, I would need to multiply by 2 over 2. I'd end up with negative 2x plus negative 4. And then the third fraction would turn out to be 30 over 6. And then you can solve from there using the strategies we used before, multiplying by 6 to get rid of the common denominator. Those cancel out, and you're left with x minus 1 plus a negative 2x plus a negative 4 equals 30. Solving that resulting equation gives you x equals negative 35. In terms of taking the common denominator and multiplying right away. When we do that on both sides, I want you to think of this as the second fraction as the entire fraction is being subtracted. So now, when we multiply by 6 on both sides, when we do that, distributing 6 to the first fraction, we have 6 times the quantity x minus 1 over 6. And then we would have minus 6 times the quantity x plus 2 over 3. And then on the right-hand side, when we distribute, we end up with 30. When we go to reduce, 6 over 6 turns out to be 1. And so I'm left with x minus 1. In the second fraction, we have subtraction. 6 over 3 reduces to 2. And we're left with 2 times the quantity x plus 2 equals 30. Now when we go to distribute, we're actually distributing a negative 2, and that's where the negative 2x and the negative 4 come from. And so in that regard, when we did the first example and we added the opposite, we distributed the negative from the beginning. It's in this step here on the right-hand side where we're distributing the negative 2. Again, solving that equation to its entirety will give you x equals negative 35. Now, what to do if you have decimals? Keep in mind that we work with a numeric system that is base 10. And so if we multiply by 100 in this scenario, because we have our tenths and hundredths, when we multiply by 100, we move the decimal point 2 places to the left. And so in this scenario, 100 times 600ths moves, actually I misspoke, it's moving the decimal point 2 places to the right. And so we would end up with 6x 9 times the quantity 15 minus x. And then on the right side, 7 times 15. You could distribute the decimals to the parentheses and things of that nature, but sometimes it's more beneficial to work with whole numbers. Solving that resulting equation will give you x equals 10. In the example listed here, we would multiply by 10 because our decimal point is in the tenths. And so when we do that, we need to multiply everything by 10 because whatever you do to the left side, you do to the right side. And so you end up with 9k plus 13 times the quantity k plus 300 equals 6,100. Yes, you need to multiply on the right side because whatever you do to the left, you have to do to the right, even though there is no decimal. Please consider the 3 equations that are on your screen. If you examine the 3 different scenarios, in scenario A, the variable cancels out, but we have a true statement. In scenario B, the variable cancels out and it's a false statement. And in scenario C, we have a single value for our variable. This leads to 3 different solution sets. We have one solution. When we have a false statement, we have no solution, meaning no value for the variable will work in the equation. And in this scenario, we have a scenario of all real numbers, meaning any number we can substitute in for our variable would make both sides of the equation true. This last slide is a summation of the different types of equations. We have conditionals, where we have one solution. We have identities, meaning something equals itself, so we have infinitely many solutions. And we have contradictions, false statements, where we have no solutions.